Hi guys, I hope you are fine. Me too, I'm fine. We give glory to God for yet another opportunity for us to learn. And so, guys, let's go now to the question. And I read the question. Given that in is equals to that is integral of x raised to n multiplied by e raised to 2x dx, prove that in is equals to that. Hence, evaluate. So the first thing, guys, we are going to integrate so that we can prove that this is equals to this. And this one we do integration by parts. And our equation for integration by parts, let me just write it. So this one is supposed to be like this. U dv is equals to uv minus integral of v du, like that. And so, guys, we come and write our equation now. Our equation now is supposed to be like this. X raised to n, then we have e raised to 2x, and we have the dx, like that. And so, guys, we now come and say we want to say this x raised to n, let's give this one the value of u, like that. So that now we have the du dx is, let me put dx this side because I'll put this side but still I'll transfer this side. So let me put it this side. So if you differentiate that, you shall get n x n minus 1, then I write dx there, like that. I hope, guys, that is okay. Then we come to this. For this one, guys, we give it a value. Let me give it a value of dv. So I say this is the dv. So that now v is going to be integral for that. The integral for that, guys, is going to be 1 over 2 e raised to 2x. I can still write e there because 1 does not affect it. Raised to 2x, like that. So now, guys, I come and now replace in my equation. So I already have this. So now I want to come and have my u. So this is going to be equal. When I write equals there, guys, here we have the integration. This is the integration we have here. So maybe I can even write it in terms of in, because this is our in. So let me write in. This is the same as the in. Which one? The one that we have at this point. We have it here, in. That one. So it represents that. Then we shall have our u is supposed to be x raised to n. Then our v is supposed to be this v, which is e raised to 2x all over 2 minus integral of v, I write that, e raised to 2x, like that, all over 2. The 2 I can bring it this side, all over 2, like that. And then we have du. The du is supposed to be n x raised to n minus 1, and then we have the dx here. So guys, let me come and now rearrange my equation. We shall have in, or rather let me just write the equation here. X raised to n e raised to 2x, then dx, like that. This one will give us, or gives us, x raised to n e raised to 2x all over 2 minus, I can bring forward my n so that we have n at this point, that is n all over 2. And then here I'm left with x. First of all, let me just write x raised to n minus 1, and then I can write e raised to 2x, and finally I write dx, like that guys. So that now guys, we can just have a comparison. We compare this equation guys, we compare this, and also we compare this. If you look at x here is raised to n, here x is raised to n minus 1. And then if you look at this one now it's similar to this. So this one we are calling it I raised to n. So, and then if you look at this guys, you can see that it's actually is very similar to this, only that this one has n minus 1. And so guys, we shall call this one I, because all other places are the same except here. So this one will be I n minus 1, and then we put our figure here, n all over 2, like that. And then we put this x n e raised to 2x all over 2. So this is equal to that. So guys, we can see this is what we are saying. That is what we have found out, because the equation here we are given, which is in, is as a result of x being raised to n. All this remains constant as of this, like this one. So this one will be like that. And so guys, we are able now to prove our equation here. If you can see it here, this is what we were supposed to prove guys. And I believe through this, we've been able to prove it. And so guys, this is our equation that has been proved. As you can see, it's actually, or it's similar. So let's go to the next question guys. And the question says, hence evaluate. So guys, we are evaluating. Let me write the question here. We are supposed to evaluate integral x cubed e raised to 2x dx. So guys, this is what now we are going to evaluate. And when guys we are told hence, it means guys we are going to use this equation for that. And so guys, we are going to write like this. For us to use this equation, we shall say that n, let me write n, then should be equal to 3. Because as you can see here, you see in, and this is the n. So here we find which one is similar. Here we have x raised to n, x raised to 3. So our n is going to be equal to 3. So we can write I3 like that, just like we have here n and we have here n. So this is going to be I3. This is going to be equal to, so we come and write x raised to 3 like that. Then we have e, this other one remains constant, just as it is written there. This will be minus n again here. So here we shall write 3 over 2. And then this one is now going to be, for this one, it's going to be I n minus 1. This means it's now going to be 2, like that. So guys, after we have that, this is what now we are going to do. So we shall bring the equation here. Let me write it here. I come and write I3 is equals to x raised to 3, like that, e raised to 2x all over 2 minus 3 all over 2. So now we come and integrate that, I2. And our I2 will take this format, so that our I2 will be like this. So that now when we come here, we shall write x raised to 2. Because now I2, if this one is 2, then this one should be 2. All over 2 e raised to 2x, like that, minus, this one is supposed to be n. So our I2 is going to have a 2 here. We are going to put a 2 there. All over now 2. 2 is constant. And then we put I1 like that. So that is how our equation is going to be, guys. So we continue. That is for I2. So guys, we continue, and let's first of all find that. So that one will be equal to x raised to 3, then e raised to 2x all over 2 minus, this one is going to be minus 3 over 4 x squared e raised to 2x, like that. Because of this minus, this one is going now to change. So it is going now to be plus I1, like that. So guys, we now come and solve for I1. So for I1, maybe I can bring it here now. Now we are solving for I1. For I1, we still use the same equation. We come and say this is going now to be x raised to 1 e raised to 2x, like that, all over 2. Remember, we are dealing with I1. This is what we are dealing with, guys. So now from there we shall have minus, the n is going to be now 1 all over 2, and then we are going to have I0, because now it's going to be 1 minus 1, which now gives us I0. From there, guys, I come and write everything now. Again, I write everything. So we shall have x cubed e raised to 2x all over 2 minus 3 all over 4 x squared e raised to 2x, now plus, this is x. And now, guys, I want to observe this, that this 3 over 2 is supposed now to multiply this, all this, whatever there is I raised to 1 is supposed to be multiplied by 3 raised to 2. And so, guys, we are going to multiply here 3 all over 4 now. As you can see, guys, here we had 3 over 2 and the I1 is within that bracket. So we had to multiply by 3 and multiply by 2. And that's why we are getting now 3 over 4. Then I put x e raised to 2x minus, I continue to multiply. This is going to be 3 over 4. Again, and then we put I0 like that. So, guys, we are almost completing. So, guys, I come and write the equation down here now. So we have x raised to 3 all over 2 e raised to 2x minus 3 over 4 x squared e raised to 2x plus 3/4 x e raised to 2x now minus 3/4, and then now we are going to work out I raised to 0. So, guys, for I raised to 0, we shall still use our equation right here, guys. This is our equation. So we shall write x. First of all, we shall write x raised to 0. All of us knows that when a number is raised to 0, it actually becomes 1. So we shall be left with the e raised to 2x all over 2. As I have written there, this is what we are going to be left with, because x raised to 0 becomes 1 minus, now, guys, here is where there is a trick, because we have n over 2 and our n is 0. So this one is actually not going to be there. So it's like this, guys. If I put minus n, which is 0 all over 2, so this one becomes 0. So finally, guys, this is now going to be our solution. So we are going to have now 3 over 8, but even if I leave it like that, guys, it is quite okay. So this is our solution, guys, for that problem. And so, guys, thank you for listening to me.